The first thing that we want to do with these packets here is actually put the outcrops together and correlate them. And it says base your answers on questions 1 through 3 on the 3 bedrock outcrops below and on your knowledge of earth science. The outcrops are labeled 1, 2, and 3, located within 15 kilometers of each other. Lines A, B, and C, D represent unconformities, and line XY represents a fault. No overturning of the layers has occurred. So the first thing I'm going to do is I'm going to try to match up and correlate layers together. So if we take a look, we see tan sandstone and green shale right here, brown siltstone right here. I'm going to match those up with each other. Now what I notice here is I have an unconformity right here, and I have this white limestone. That means that there's something missing there, and when I connect these two, it turns out I can find out that the layer that's actually been worn away here during this time of uplift, weathering and erosion and subsidence was this particular green shale. So that concludes what I can do between these two. Now I'm going to see what I can do between these two over here. And what I see here is I see some white limestone that I can line up like this. And above that white limestone, I see that we have this unconformity over here. And we have this green shale right here. So it looks like in this area, gray sandstone that was wiped away. So in a way, if you look at this red sandstone is coming all the way around, coming up over here. This gray siltstone is coming all the way around and coming up over here. And this brown sandstone is coming all the way around and coming up over here. Now, if I wanted to order this, I could figure out which layer is at the very bottom. And it turns out the layer that's at the very bottom of all of these would be the gray limestone. So this would be number 1, this would be 2, this would be 3, this would be 4, this would be 5, this would be 6. Now, because I have this unconformity here, I'm going to stop labeling things, but here's what I can do. I can go across over here and say if this is layer 3 over here, this is 3 over here. Gray siltstone's number 4 over here, so it's going to be number 4 over here. Red sandstone's going to be number 5. White limestone is number 6. Tag it over here and put it in here. Now I know this is number 6, which makes this number 7. Number 8, number 9, number 10, number 11. Now, the reason I was able to do this whole row up to here was because there's no unconformity in here. But now if I look over here, this number 8 goes over here as well. You can see that layer 7 is missing between these two. This number 8 goes over here. And you can see that layer 7 is missing between those two. Here is layer 9 and layer 10. Now we can take a look at the questions. Based on the evidence on the diagram, which rock layer is older than fault XY? So here is fault XY right over here. And all of the layers that are cut by fault XY are going to be older than that fault. So let's see, tan conglomerate. Tan conglomerate is up here, so it happened after the fault. It is younger. Black shale. Black shale is cut by the fault. That looks like a good choice. Brown sandstone, let's see, or brown siltstone, that's over there, so that's not okay. And white limestone, that's the number 6. That puts it above the fault. That would not be a good choice. The unconformities A and B resulted from, this is a standard question about unconformities. Unconformities happen when you have uplift and erosion followed by subsidence and deposition. Which layer is the youngest? Well, we now know that this is the highest number on the list, which makes it the youngest feature. Let's see. We have red conglomerate there. There it is. All right, let's take a look at this second page here. One of the big features I see here that's really easy to align is this volcanic ash with a tan limestone. So I'm going to get started on that just by connecting the volcanic ash from one to the other. Now I see tan limestone. I'll match that up over here. And conglomerate match up over there. And we have the green shale under there and the gray siltstone over there. Next thing I want to do is just continue to the next area here. There's a unconformity right there. There's a red sandstone, gray limestone, and then black shale. So now when I have this all wrapped up, I want to figure out what happened first. This is the lowest layer of all of them, so this would be number 1. Now, that's number 1. I do have an unconformity right here, but I have nowhere else to go, so there's number 2. That makes this number 2. Here's number 3. Makes this number 3. Unconformity, unconformity. Now we have number 4, 4, 4, 5, 5, 5. Volcanic is 6, 7, 8, 9, 10. Continue here with 7, 8, and over here 7, 8, 9. We want to find out what is the youngest geological feature. All right, if we take a look at the lowest 3 layers that we have here, we have a fault, we have a igneous intrusion with some contact metamorphism, and we have an unconformity. Now you notice that the fault cuts across all 3 things. It cuts across the unconformity, it cuts across the igneous intrusion with the contact metamorphism. Therefore, the best answer on here is fault. Now the other ones, I said the unconformity, the fault cuts across the unconformity, the fault cuts across the igneous intrusion, and the zone of contact metamorphism. Which sedimentary rock shown on the outcrops is the youngest? So we determined by numbering these that the tan siltstone would be the youngest feature. Okay, question 6 and 7. We're going to line up our chart again, and one of the things I see here is tan limestone, black shale, red sandstone. They're all matching up with what I see on the side here, so I'm going to match those up. Okay, so that's done. And then over here I see that tan limestone with the ammonoid fossils up here with the black shale above it, so I'm going to match these two up. Do you see an unconformity in here? And that makes sense now because I see a layer is going to be missing from here that the limestone's going to match up, and this is going to match up like this. Technically speaking, these two would match up all the way across like this, and this would actually be the lowest layer. So here's number 1, 2, 3, 4, 5, 6, and 7. And the reason I can just go up like this, there's no unconformities there. I'll move the 3 over to here. So there's 3, 4, 5, 6, 7, 8, and 9. Over here, this matches up over here. So here's 2, 3, 4, 5, 7. There's the unconformity, missing a layer in there, and number 8. So an unconformity can be observed at location Z. Which rock layer was probably removed during the time here? You can see in between here and here, we have the conglomerate has been removed. Which rock layer is the oldest? I'm going to have to go with this gray siltstone. That was the layer that was at the very bottom. All right, let's take a look at the last chart here. We start matching things up right away. We see some green shale here, green shale here. We've got an unconformity in both ends here. Looking for clues on the other side here. Brown siltstone, tan limestone. Tan limestone's down here, followed up by an unconformity above it. And there's some green shale, so there's a layer that was worn away during the unconformity time. We've got the conglomerate and the brown siltstone. So now, when we look at this, this over here would be number 1, 2, 3, 4, 5, 6. I'm going to stop there because I have that unconformity right there. We want to continue by bringing this over here. So there's 3, 4, 5, 6. I'm going to stop there because there's the unconformity right there. We'll take that down here. Here's number 6. Here's 7. Here's 8. Here's 9, 10, and 11. Now I'm going to go back here and establish that this is number 8 here, 8 here, number 9 here, number 10 here, and this would be 11. Which rock would most likely produce by metamorphosis of gray limestone? So when limestone is metamorphosed, it will change into the rock marble. When did fault XY, located in column 1, most likely occur? Let's take a look at the choices. Before the formation of the gray limestone. So the gray limestone is down here, so it's below the fault. It must have happened, the fault must have happened after the gray limestone was there. During the formation of the gray siltstone, the siltstone had to be there already. It couldn't happen during. During the formation of the black shale, once again, the black shale had to be there for the fault to occur. After the formation of the red sandstone. So what you see is you do see the red sandstones cut by the fault. Means the red sandstone had to be there already. So there is our correct answer. What is the oldest layer? So which layer is found at the very bottom of all these? The first number on the list is that gray limestone right there. So that would be considered to be the oldest layer.